outcome. I haven't hit it already, still working, I'm still learning, I'm still searching, finally earning something, finally turning something called a profit. If I hear you talking.
Wind 020 at 8, visibility 4 miles with mist. Sky conditions scattered 1,600, ceiling broken 3,100 and broken 4,300. Temperature 20.1, 9er, altimeter 3005.
Have you heard the transmission of air traffic controller? He's mentioning altimeter, isn't it? Okay, we'll hear it once again.
02.1, 9er, altimeter 3005.
So, QNH is the barometric altimeter setting that causes an altimeter to read airfield elevation. The airplane's altitude is defined as its height above mean sea level. You might be knowing that mean sea level is the average level of water in the sea. The sea level is constantly changing, isn't it? It's rising and falling due to the effects of the gravitational forces of the moon. Going forward, QNH is the atmospheric air pressure that has been adjusted to the mean sea level. Generally, QNH is expressed in hectopascals, For example, 1004 hectopascals in the low level atmosphere where training aeroplanes fly usually. Air pressure decreases as altitude increases at a relatively constant rate. The altimeter senses air pressure and calibrated to estimate the aeroplane's altitude above the mean sea level. Air pressure decreases as altitude increases at a relatively constant rate. The altimeter senses air pressure and calibrated to estimate the aeroplane's altitude above the mean sea level. For every location on Earth, the mean sea level pressure does not remain constant, but it changes due to the changing weather, as you might be knowing that. Pilots must ensure that the correct QNH is set on their altimeter for the location which they are flying in. This specific QNH can be obtained from weather observations and reports, which is generally disseminated time to time. When QNH changes, the pilot must change the QNH on the altimeter. When aeroplanes have the same QNH, their altimeters are synchronized, so the altitude readings are also synchronized and correct vertical separation is maintained.
You look to your right, in a few seconds after the visualization showing you the third highest mountain on Earth, which is Mount Kanchenjunga, and it stands at 28,170 feet above mean sea level, or 8,586 feet. That's Mount Kanchenjunga towards your right in a few moments. And on this route, weather permitting, we should be seeing some of the highest mountains on Earth, including Mount Everest. Ladies and gentlemen, if you look to your right, I'm happy to show you some of the highest mountains on Earth, including Mount Everest. But the first one you'll see from your right to your left will be Mount Makalu, which is the fifth highest mountain on Earth at 8,463 meters or 27,766 feet. And after Mount Makalu, you'd see Mount Everest. It's a pyramid-shaped mountain behind a ridge. And you can see some snow being blown off its peak. It's the highest mountain on Earth at 29,035 feet or 8,850 meters above mean sea level.
Mount Everest, for example, is an amazing 8.8 kilometers the height above sea level. So flying at 10,000 meters doesn't give you that much room to maneuver. Then there are other planes to avoid, and it's actually more efficient to fly at high altitudes where the air is thinner and overcoming air resistance uses less fuel also while flying. All told, there are plenty of good reasons for flying high, but how high? It matters very much whether pilots know how high in the air they are flying. After all, they can always peer through the windows, isn't it? But measuring altitude, your height above mean sea level, I mean to say altitude, is much more important to a pilot than you might think. Some of Earth's mountain ranges are surprisingly high and harder to miss in bad weather. We'll come back to the factual topic. How does a pilot measure a plane's height in the air? Simple, using a handy gadget called an altimeter. Have you heard about altimeter? Okay, let us take a closer look at what these things are and how they work. Okay, altimeter measures the height of an aircraft above a fixed level. I mean to say, the instrument senses this by taking the ambient air pressure from the static port. Inside the altimeter is a sealed disc called an aneroid, or even we call it as bellows. As the aircraft goes up, the pressure inside the case decreases and the bellows expand. The opposite happens as the aircraft descends. The bellows are mechanically connected to the face of the instrument through gears. The window on the front side of the instrument allows the pilot to set the altimeter to the current lock-up pressure, so it will display an accurate height above sea level. It looks like a clock, But it's not a clock. The big hand is at hundreds of feet, the little hand is at thousands of feet, and if there is a small white line, it reads in tens of thousands of feet. At this time, I remember the inventor of altimeter. Altimeter is Colesman's invention that assists the pilot. Who is Colesman? Colesman is a German-born engineer who invented the Porsche altimeter in 1920s. He was granted the use patent too. Let us see where this word altimeter is derived from. It's borrowed from New Latin. From Latin, altus means high, so the meter measures height. We spoke about air pressure. Why do we have air pressure? Earth's gravity pulls everything toward it, and everything includes even the smallest things you can imagine, like molecules of air. If you are an air molecule near the ground, you have got lots of other air molecules above you pushing and squashing you down. Higher up, there are fewer molecules and there is less pushing. That's why air pressure is highest at Earth's surface and gradually falls in a systematic way the higher up you go. Measuring the air pressure is therefore a simple and effective way of measuring altitude. Flying is an adventure for most pilots, sometimes more adventure than they really want. A pilot's report to Canada's aviation safety, reporting program about an attempt to land through low clouds on a remote, icy runway is an example. The airplane's altimeter indicated that the airplane was still 300 feet above the ground, but the nose wheel struck the ice, the report says. The pilot immediately applied full power, climbed away from the ground, and returned safely to the departure airport. What happened here? The air pressure was lower at the destination airport than at the departure airport, But the pilot had not reset the altimeter because the airport didn't have radio weather data. About the altimeter, hikers and mountain climbers even use wrist-mounted or handheld altimeters, in addition to other navigational tools such as map, magnetic compass, or GPS receiver. You can say even the parachutists use an analog, that is a pointer and a dial display. This one is being worn by a marine about to make a parachute drop from 10,000 feet. Not everyone wants to wear an altimeter all the time. However, altimeter watches with the digital LCD displays, such as those made by Suunto, are more popular with hikers and mountain climbers. Some use built-in barometers. Radio altimeters are much quicker and more precise than pressure instruments and are widely used in high-speed airplanes or ones that need to fly at particularly low altitudes, such as you can say jet fighters. Here I end this session. Next time I will be coming up with the aviation lessons. Until then, bye.
Let's go.